All right, so we have some very familiar pieces in here. We've got H and K. We love those guys. We know what they do. H does our horizontal transformation, scooches it left or right. K does our vertical transformation, shifts it up or down. R is going to be our radius, because these are circles. So it's going to be how far away from that center we go. So just like how when we had like parabolas and stuff, our vertex would be at HK. When it's a circle, that's just our center. That's where the middle is. And our radius will be R. Shockingly enough. So what we're going to do is we're going to start by looking at some equations of circles. We're going to figure out what the center is and what the radius is.
Oh, yay.
So I'm going to give you guys 3 graphs. Here's the My brain did not process it all there for a hot second. I was like, I was like, teddy bear baby. All right. Do we need more time on this page? We're good. Do we need more scissors? Yeah. I got more. Yep. So this is the first one we're going to look at here. We're going to figure out what our center is, we're going to figure out what our radius is, and we're going to graph it. I'm going to write our little formula up here again, just above it. So we're going to work with the quantity x minus 3 squared and the quantity y minus 1 squared. And that's currently set equal to 16. So we need to find our h, we need to figure out our k, and we need to figure out our r. What is our h here? 3. What is our k here? 1. What is r? 4. Because this is r squared. So if you need to, or especially if it's not a pretty perfect square, what we're going to do, we could set our, whoa, wrong pen. R squared equals 16. So our r equals 4. Square root both sides. Since we're looking at a circle here, our radius is never going to be negative because I can't have like an inverted inside-outy circle. Mm-hmm. So the radius will always be a positive value. So that means we know where our center is. Our center is going to be at the point HK, or the point 3, 1. So this is our center. So that's where we're going to start. We're going to start at the point 3, 1. So I'm going to plot the point 3, 1. We're not going to need to get out like a compass or anything for a circle. We're going to get it as close as we can. Mine's oftentimes wind up looking very squircle. But we're going to figure out how to get our radius of 4. So if this is my middle, and I need a radius of 4, it means I'm going to go outwards 4 in all directions. Well, I've got 4 very easy directions in which to count 4 spaces. Up, down, left, right. Exactly it. We're going to go up. 1, 2, 3, 4. So we're going to have, there's 1 point. Where's the radius of 4? I'm going to go to the right. 1, 2, 3, 4. Got one right here. I'm going to go down. 1, 2, 3, 4. This gives me a point. And we're going to go left 4. 1, 2, 3, 4. So those are kind of like guideposts for us, for our circle. We're going to do the best we can and do not overthink it. Don't use straight lines. There shouldn't be any corners on your circle. Do the best we can. But again, I'm not an art critic. We're going to get the vibe of the circle. And if it's a little squirkly, not too bad. That's not a terrible one. As long as you don't have a corner, we're probably fine. No corners in your circles.
Mine looks like one of those like rounded.
I was gonna say, if it looks like a Post-it note where I've cut the corners off a little bit and rounded them, we're okay. Just get it as round as we can, but don't overthink it. It's not that big a deal.
Everything.
We don't need to overthink it too hard. Again, not an art critic. I am not good at drawing. That is not a skill I possess.
Is that all we're supposed to do with that?
Yes. We're going to do more things with them. We're just practicing this a couple of times first. Yes, dear. Oh, you guys need glue? Yeah. Yeah, if you ever need replacement glue or more scissors or left-handed scissors, anything like that, let me know.
There's a difference between types of scissors.
Yes, there is. There is. My mom's left-handed, so I'm already quite aware of it. And in fact, I want to say it's about 50 people a year that die from using right-handed products when they're left-handed. Because things are designed for right-handed people.
I don't understand.
So these are actually left-handed. I was gonna say the little notches wind up on other sides. How your stuff fits, like how your thumb fits in there. If you hold it with your other hand, it like doesn't fit right because the little thumb notch isn't there.
That makes more sense now. What, Imari?
The snark.
You are? Yes. Okay, I thought we've already established that it's Friday and I'm slow.
It's okay. It's okay. It's also, how often do we think about what hand someone else is writing with? If it doesn't necessarily affect you, we don't tend to pay attention to it. And the only reason I was super aware of it is because my mom's left-handed. All right. So on some of these, all we got to do is just graph them. We're finding our H, finding our K, finding our R, and graph them. We're going to do it again. We're going to remember this. We're going to try and practice this. There we go. Lincoln. All right, so we've got x squared plus the quantity y plus 3 squared equals 9. So we want to find our center. We want to find our radius. Mm-hmm. I don't have anything inside the parentheses with my x. So my h is 0. There's nothing there. So my h is 0. What's my k? -3. My k is -3. what's our radius? 3. Our radius is 3. Okay, because r squared equals 9. Honestly, that's the mistake I have people make most often, is we're just kind of like flying through like, oh, easy peasy, r is 9. No, r squared is 9. R is 3. So make sure we're pausing for a moment to think instead of going, oh, easy peasy, bloop, bloop, bloop. So our center at 0, -3, going to be down here. And then when we have our radius of 3, we're just going to go out 3. So up 3, right 3, down 3, left 3.
Okay, so I am going to be right behind.
And we're going to connect them up as best we can. There we go. That looks like a face, but no, close enough. It's giving anime, but again, I'm not an art critic. We get the point across. Make sure I can tell it's a circle. Good enough.
It looks like an alien.
It does look like, mine looks awfully alien-esque. Again, not an art critic. I'm doing the best I can, but we're not going to overthink it. We're not going to get out like a compass. Compass tools are gross.
Compasses are actually really cool.
They're cool, but using them mathematically, technically, is obnoxious and slightly dangerous because they're very pokey. They're sharp on one.
Mine, to be fair, mine is enclosed in like a thingy.
Yeah.
But like.
Old school compass is almost a needle on one end and a pencil on the other. Very, very sharp. Okay. Questions on these ones? I pick it up a small notch.
Oh Lord, I'm scared.
Small notch.
A small notch?
Small notch. Okay, pick it up a small notch here. So now we have 2 times the quantity x minus 4 squared and 2y plus 3 squared equal to 8. I'm taking note. Write it down. Give us a second to write it down. Yes, but when you're exactly right. Nothing. We had a thought. I was confirming that yes, they're on the right path. But only give us a second to write it down before I start plowing through. Try not to go too fast. I get excited. I actually like circles. I'm not easy to draw. Circles are fun and interesting and fascinating. And the birthplace of mathematics. All math is born from circles.
Really?
Yes. Because before they even had numbers, you could prove things were equal using circles. They had the same radius. So you would just draw circles and circles and circles. That's why I have a circle like this. All math comes from circles. As before there were numbers, you could do math with circles. Before there was, like, without any language translation, you would convey your math with circles. All math is doable with circles. Not easily, but it's doable. All right. So we've got a number out in front here, and our formula did not have any numbers out there. What could we do to maybe not get 2's out in the front? Divide everybody by 2. Because if I divide this piece by 2 to get rid of that 2, and I divide this piece by 2, because they're on the same side, I got to divide everybody. As long as I do that, and to everybody, I can do whatever the heck I want. So if we divide everything by 2, that's going to give us our x minus 4 squared plus our y plus 3 squared equals 4. We can do that. Now it's exactly like it was before. We just had one little step. I told you, it was just a little baby expansion. It was just a smidge harder. So, where is our center going to be on this one? 4, -3. And what is our radius going to be? 2. So we're at 4, 3, 4, negative 3, 1, 2, 3, because mine doesn't have any numbers on it. And we have our radius of 2. So we go up 2, right 2, down 2, left 2, and we're calling that good enough. Like that. That's a long, you guys are not bad. I've done worse. Instead of the 4 being negative. Because our formula, when we're thinking through that original formula, it was our x minus h squared and y minus k squared. Since it's inside the parentheses, it's got that opposite sign, like the opposite. When it's inside the parentheses, it gets that opposite effect. Miss Hannah thing. Okay, so when we're set up in this like parentheses with the perfect square form, everything is nice and lovely.
I'm scared.
We're gonna get through it.
That's
They don't always hand it to us in the nice, easy, I like to graph it this way kind of form.
foreshadowing.
Yeah. So, sometimes they give us an equation. I'm going to put the equation up, and then I'm going to put up like a page, and then we're going to go back to it. So sometimes they're going to give us stuff like this.
Oh, geez Louise.
Where we have 3x squared plus 3y squared. And we got minus 12x, and we got a plus 18. And all of it's equal to 0. And we want to try and graph that thing. All right. Well, that's okay. We don't actually have to graph them. We're going to find our center and radius. We'll call that good. What we're going to have to do is we're going to have to do completing the square, which we've done before, but it's been a second. So I'm going to put up the instructions we had for completing the square in case we need to copy those down again, and then I'll come back to this. I'll give you guys a second to write the equation down. Yep. So what we're going to have to do is we're going to have to, I'm just putting, like, these are instructions for completing the square. If we have forgotten how to complete the square, this is the way we do it. So we're going to have it equal to 0. We're going to put our x's in one group. We're going to put our y's in one group. We're going to figure out how to make them perfect square trinomials. And that's going to give us this form. So if we have forgotten how to complete the square, these are kind of our step-by-step instructions. You can take a picture, you can speed write, you can pull them up on the PDF when I get them posted in 5th period. Whatever we want to do.
Is that like the cross of the square?
It's where we're trying to make the perfect square trinomial so I could write it as like x plus 2 squared. So like when we first did this, so we'd have like x squared plus 6x plus something. And we have to figure out what goes there. Where we took our b over 2 and then we squared our b over 2. That guy. So in this case, we would add 9 here, which means we'd add 9 on this side. So that we could write it as our x plus 3 squared. So this would be our perfect square form of this perfect square trinomial. That's what we're going to do. We're going to put our x's together and figure out what we need to add. And then we're going to put our y's together and figure out what we need to add. So I'm going to take it back over here. So first thing I'm going to do is I'm going to rearrange this. I'm going to put my 3x squared minus the 12x. And then we're going to have our 3y squared plus the 18y. Actually, don't need the gap there. That was just my brain buffering. The gap was not intentional on that one. That was my brain buffering. When we're doing our perfect square forms, we don't really like to have those numbers in the front. So I don't want to have 3x squared or 3y squared. I want to just have one of them. So to get rid of that 3, I want to divide absolutely everybody by 3. Because I don't want to have to do the perfect square with my 3x squared. I mean, it's doable, but it is unpleasant. So we're going to have our x squared minus 4x and our y squared plus 6y equals 0. Now those gaps are intentional. Because if I just look at my x's here, what could I add there to make that be a perfect square trinomial? It's like it would our b divided by 2 would be 2, which makes this thing 4. So if I add 4 right there, which means I have to add 4 to the other side, I could rewrite this piece as our x minus 2 squared. Yes?
Wait, oh, it means like tangent.
Then we're going to do the same thing with our y's. So if we plus something here, what do I need to add to my... Because we take our 6 divided by 2, and then we square it. So that gives us a 3, and then square it, we add 9. So I'm going to add 9 to this side, and I'm going to add 9 to this side. Because I have to add it on both sides. That is the wonkiest line I've ever written, oh my gosh. Because then I can rewrite this thing as our y plus 3 squared.
Could you slow down?
Yep.
I ran out of lead. Pencils. I have lead.
Okay.
I just ran
Yep.
out.
So these two pieces, I'm just going to finish out this one. We've got our x minus 2 squared plus our y plus 3 equals our 4 plus 9, 13. So we can make them be perfect squares using our completing the square stuff. Which is part of the reason I only gave us 3 graphs, because ew. If we're getting radicals for our radiuses, we're not gonna draw them. Like ew. So what, there we go, almost threw my stylus. What is our center here? 2, negative 3. What is our radius? Square root of 13. Which is gonna be 3 and change. I'm gonna go with about 3.7-ish. Braining it. Okay, so sometimes we're going to give it to them when they're not in their nice, pretty circle form. 3.6, that wasn't far off. But that's also the reason I didn't give you more graphs. I don't want to graph square root of 13 as a radius. Ew. Graphs. Not going to have it. Okay. Questions on this one? Because we're going to try it again. Because they're weird and they're awkward. And we're going to see them for several different kinds of things. Another one. So here we've got 2x squared plus 2y squared minus 12x plus 4y minus 15 equals 0. Lots of pieces. What's our first instinct? Don't say cry.
Add 15.
Yeah, we can get the 15 to the other side. Absolutely valid. At the same time, I'm going to do my shuffle. Put my x's together, put my y's together. So I'm going to have my 2x squared and our minus 12x and our 2y squared and our 4y, we can deal with fractions, equals 15. Eyes hurt, Sky? Yeah. Because what are we going to have to do next? Everybody gets divided by 2. I'm going to say, there's ways to do it without winding up with a fraction, but it's honestly less pleasant. So dividing absolutely everybody by 2, that's going to give us our x squared minus 6x plus our y squared plus 2y equals 15 halves or 7.5. Either way is fine. I tend towards fraction because it keeps things accurate every time. Decimals sometimes aren't the best. Because if it was like thirds, then we're rounding and then we've changed our answer. So halves you can do as decimals, quarters you can do as decimals, totally valid. Tenths we can do as decimals, totally valid. Things like thirds we don't want to round off. Questions on that part? It's a lot of kind of weird. It's all just a little bit weird.
Just a little bit.
Okay, so it's tangent to the y.
All right, so then we look individually. What do I need to add to my x's bit? 9. Because that negative 6 divided by 2 gives us a negative 3. Negative 3 squared gives us a 9. So if we add 9 to this side and also add 9 to this side, my equation's still balanced. What am I adding into my y's to make this be a perfect square?
4.
1. 2 divided by 2. 1. 1 squared. 1. So it's our b divided by 2 squared. So we're going to add 1 here, which means I also need to add 1 over here because I got to keep my equation balanced. I can't just randomly add 1 to the left side. Then my equation's no longer balanced. So when we're writing these in their perfect square form, what is this one going to be? X minus 3. Absolutely right. And what's the y one going to have? Y plus 1 squared. What's on the other side?
That would be 15 halves plus 10.
2.5.
I would say 15 halves plus 10 is right, but we're going to get there. You can also put them in the calculator, like 35 halves. So adding 9 plus 1, we get 10. 10 is written as halves, would be 20 halves. 15 halves plus 20 halves, 35 halves.
It's 2.5.
Should not be 2.5. The 15 was negative over here, but if I add it to the other side, it'll equal sign. Okay. That's 100% why we have this and we can ask questions. Okay. Valid. So what is our center? 3 and negative 1. What is our radius? Root 17.5 or root 35 over 2.
Also known as U.
Also known as U. Also known as why we're not graphing it. Because root 35 over root 17.5. It'd be 4 and change, 4.18, blah, 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 blah. Okay. Questions on this one? We're not. We won't grab them when they're decimally like that. If we get a radius that's a decimal, it would be something like 0.5. Because that's way easier to eyeball. But that's why we're not graphing this, because but it would be done the same way. I'd count out my 4.3, 4.1, whatever, and we'd estimate. Graphing by hand is always an estimate because we as humans have error. We are not perfect. We are not robots. We are not computers. I do not expect computer perfection from humans. Okay. So sometimes the book will ask us questions in a weird way. Where we're asked to write equations for circles given vibes. So sometimes they'll tell us the center and the radius. And we will go through that. So if we know that the center is at 2, -3, if we think through our equation, like our formula, we know that. That's our y, x minus h squared plus our y minus k squared equals our r squared. So our equation on this one, we're going to have our x minus what? 2 squared. And we're going to have our y plus 3. Y minus -3, double negative becomes a plus 3 squared. And it's going to equal what? 25, 5 squared. Ta-da! Oh, when they hand us the radius, it's not too terrible. Then we have this next one here. They're giving us a center, and they're telling us a point that it goes through. But they don't, like, straight up tell us the radius or anything.
Can't you just like imagine it?
Can we, it's like we are going to do something where we're working with 2 points. If I know my center is at -2, 1, and it's going to go through 3, 4, 1, 2, 3, 4. How could I figure out how far away this point is? The distance formula, because that's going to be our radius. But we can do the distance formula to figure out what it is.
Yay.
So the distance formula is making a comeback. So we know that the distance between these 2 points is going to be the square root of we find the sum of our x's, sum of our y's, or the difference in them. So we're going to have our 3 minus -2, or 3 plus 2 squared. And we're going to sum that with the change in our y's for -1 squared. It's all numbers over here, so we can do this. So then we're going to have our square root of 3 plus 2 gives me 5. 5 squared is 25. 4 minus 1 is 3. 3 squared gives me a 9. And so my distance here is the square root of 25 plus 9. 34. So that tells me the distance between my 2 points. That distance is also known as my radius. From the center to any point on the circle is going to be that radius. Because we're going from the center to any point on the wall. Every single point on a circle is the same distance away. So my radius is the square root of 34. We don't want to make it decimally. We're just going to write our equation. Because now we know we're going to have our x minus what? Right.
-2.
Minus negative 2. So we're going to have x plus 2 squared. And we're going to have our y minus 1 squared. And it's going to equal our radius squared. So square root of 34 squared, 34. Because radius is square root of 34. I want to talk to you at least one more. We don't have to get all the way to the answer, but they're going to use a weird word sometimes on some of these problems. I want to tell you what that means. Because they're going to talk about tangent. So we're going to talk about the word tangent. They're not meaning the trig tangent. What tangent means in this context is it means touching. So if we have a center at -3, 6. So 1, 2, 3. And it's going to be tangent to my y-axis. That means it's going to go like this. It's going to touch it. Tangent means touching. So what is the radius if it's at -3, 6 and it touches the y-axis? 3. Because it's 3 away from my x up here. So our radius is 3. So when I know the center, radius is 3. Okay? We will not say cosine of the x-axis. This is really the only time we see any of those words this semester. Next semester we will see them every day. Second semester is all trig stuff.
Oh, Lord.
We'll get through it. I promise we'll get through it. Okay, but that's what they mean when they say tangent. They mean touching. So our equation on this guy, we'd have our x minus -3, so we'd have our x plus 3 squared, and our y minus 6 squared, and that's going to equal our radius, 3 squared, 9. Okay, so sometimes you're just going to describe it, and at that point, sometimes it helps to sketch it out. So when they say tangent to both axes in quadrant 2, so quadrant 1's here, quadrant 2's here, looking at this guy. It's going to touch both axes. Boop. And they're telling us our radius is 4. What point is that going to be at? It's going to be at -4, 4. Because it's 4 to the left and it's 4 up. So again, tangent means touching. If we can't spot it from the words, sketch yourself a picture. It doesn't have to be pretty. That is the least circly circle I think I've drawn. At least from this angle. Okay? So don't ever think it too hard. We're going to look at some more stuff on circles and parts of circles next week. Boop. So, since I was going to say we're 3.2 is not going to be due on Monday because we did not get all the way to like parts of circles. So at the very earliest, it'll be Tuesday. Because there's stuff in there on like semicircles.
Oh, jeez Louise.
Well, a semicircle's just like a half a circle. So it's just like a part of it. They look scary, but I promise semicircles actually aren't super awful. Happy Friday. Have a great weekend. Happy almost homecoming week. It's theme days. Just as a warning, I throw down. There may or may not have been fabric dye purchased for this theme week.
I'm not surprised. So I'm like,
There was was a bolt of fabric purchased last Saturday that was plain white. It is no longer plain white nor a bolt of fabric.